the concept of shape memory alloys, let us consider first the common behaviors of materials when we apply the force to bend or deform them. So let us take this fork as an example. Forks like spoons and knives are usually made up of stainless steel, and stainless steel, like other materials with the property of plasticity, has the property to undergo deformation without going back to its original shape. So to demonstrate, if we apply a force to try and bend the fork will change its shape and is permanently deformed, meaning, once you remove the applied force, the fork will remain at its new shape. Some materials considered as brittle does not deform when subjected to stress. So if the fork is made up of wood, the fork will break if we apply a force to try and bend it. Just to demonstrate, what if the fork is made up of rubber? Rubbers, as we all know, has an ability to deform once a force is applied to it, and as soon as the applied force is removed, the rubber will return into its pre-deformed shape. This property is called elasticity. Shape memory alloys has about the same effect as this. So shape memory alloys compared to ordinary metals have a special property that once deformed, will return back to its original shape once an appropriate heat treatment is applied. And this property is called the shape memory effect. Shape memory alloys are considered as polymorphic, that is, it may have multiple solid phases. And the shape memory effect involves phase transformations between them. So at low temperatures, the phase is called the martensite phase, and at high temperatures, the phase transforms into the austenite phase. So for example, we have a shape memory wire in its normal temperature. It is in its martensite phase. In this phase, the wire can be easily deformed and its shape can be easily changed. If we deform the wire, the alignment of atoms will slightly change. And once we put the wire into a hot surface, its phase will transform into the austenite phase. The process can be repeated. So once it is in its austenite phase, it can be cooled down into its martensite phase where it can be deformed easily. When the stress is removed, the deformed shape is retained at this temperature. And applying the shape memory effect by heating the material again above its transformation temperature, the material will return back into its original shape. One way to program the wire to adopt a new shape is by forming it in a block with nails according to the shape preferred. The material is then brought into a temperature that allows the molecules to rearrange, but not too hot as to melt the wire. This step can be done by putting the block into a furnace or heating up the wire with a candle. After that, cool the wire by putting it in a cold environment or simply by putting it in a cold water. This is the new shape remembered by the wire.
How does shape memory alloy manufactured? For manufacturing this kind of advanced material, we need two types of metal that is commonly used to make SMA. One of those metals is nickel, the metal that is used for making coins, and titanium that is used for aerospace machines. These metals will undergo four different processes: melting, casting, forging, and forming. When these two metals undergo a melting process, the combination of the metals is called nitinol. There are three melting techniques that is used to melt these metals: electron beam melting, vacuum arc melting, and vacuum induction melting. After the melting process, the nitinol is ready for casting process. The majority of SMA products are cast in semi-finished form. Forging is a forming process in which the metals is forced to occupy a given geometry. Usually, the applied force is uniaxial, given a press or hammer. Forming, this manufacturing process can be either hot or cold. Although hot work products present better behavior in terms of thermomechanical properties, sometimes cold manufacturing processes are needed. Hot working is done at temperatures between 700 degrees Celsius and 900 degrees Celsius. Cold working of nitinol causes marked change in the mechanical and physical properties of the alloy. After the process of forming, your nitinol metal is finished and ready to be programmed.
We're now going to talk about some advantages and disadvantages of shape memory alloys. Shape memory alloys are very biocompatible. It is related to the behavior of biomaterials in medical fields. For example, dental wire. You can use it for braces because it can maintain the shape since they are in a constant temperature. It also has a high elasticity of the memory metal. The advantage of a shape memory alloy, it is very light unlike the other alloys we use, and it's not that hard to shape it. We can use our own hands by fixing the alloy. Shape memory alloys is a good mechanical property because it is strong and it has a high corrosion resistance. In some cases, eyeglass frames is composed of shape memory alloy. As I have said earlier, it is not easy to break. Even though you bend the glasses back and forth, it will still return to its shape. Shape memory alloys are very useful for structures, some engines and some suspensions because it can control the vibration. Some advantages some advantages of shape memory alloy, they can be used for safety devices, which will save lives in the future. For example, the fire sprinklers. It can easily determine a certain temperature. And then now we are in the disadvantages of shape memory alloys. Shape memory alloys are too expensive in manufacturing. That's why having braces is too expensive because of the material used. There are still some difficulties with shape memory alloys that must be overcome before they can live up to their full potential. It can cost a lot of money compared to the regular materials such as steel and aluminum. Shape memory alloys have poor fatigue property. It means that while under the same loading conditions like twisting or bending, a steel component may survive more than 100 times, unlike the shape memory alloy elements. In addition, the slow characteristics of shape memory alloys actuators is incompatible with high speed control. So that's all for the advantages and disadvantages of shape memory alloys.
The following is a list of some of the applications that shape memory alloys have been used for. Broken bones can be mended with shape memory alloys. The alloy plate has a memory transfer temperature that is close to body temperature and is attached to both ends of the broken bone. From body heat, the plate wants to contract and retain its original shape, therefore exerting a compression force on the broken bone at the place of fracture. After the bone has healed, the plate continues exerting the compressive force and aids in strengthening during rehabilitation. For clogged blood vessels, an alloy tube is crushed and inserted into the clogged veins. The memory metal has memory transfer temperature close to body heat, so the memory metal expands to open the clogged arteries. Lines that carry highly flammable and toxic fluids and gases must have a great amount of control to prevent catastrophic events. Systems can be programmed with memory metal to immediately shut down in the presence of increased heat. This can greatly decrease devastating problems in industries that involve petrochemicals, semiconductors, pharmaceuticals, and large oil and gas boilers.